Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today for exam LTAM. For a special fully discrete 3-year term insurance with level premiums on X being a person who is X years old, you are given the death benefits BK plus 1 and mortality rates are for K 0, 1, 2, and 2. The death benefits are 100,000, 200,000, and 300,000, and the probability of death within the next year is 0.03, 0.05, and 0.07. The interest rate is 6%. That's the annual effective rate. Calculate the net premium reserve at the end of the first policy. And here's the solution. Let us write P for the level annual net premium. We equate the actuarial present value of benefits to the actuarial present value of premiums, and we obtain 100,000 times QX over 1.06 for the death benefit in the first year. And then the second term that 100,000 is multiplied by is 2, because the benefit in the second year is 200,000, times PX, survival of the first year, times QX plus 1, death in the next year, divided by 1.06 squared, because the benefit is paid at time 2, so the present value needs to be calculated by discounting over 2 years at 6%. And plus 3, because the death benefit in the third year is 300,000 times PX plus 1 times QX plus 2, corresponding to probability of dying in the second year with the death benefit paid at the end of the second year. Third year at the end of the third year. So first year, second year, third year death benefits are accounted for here. And that's equal to P, the premium, times 1, because the first premium is paid with certainty, plus PX over 1.06, that's the premium paid at time 1, plus PX times PX plus 1 over 1.06 squared, for the premium paid at time 2, and the premium is paid at the beginning of each year. And we just solve this for P, and P is equal to 100,000 times QX over 1.06 plus 2 times PX times QX plus 1 over 1.06 squared plus 3 times PX plus 1 times QX plus 2 over 1.06 cubed divided by 1 plus PX over 1.06 plus PX times PX plus 1 over 1.06 squared. And every single of these values on the right-hand side are in the table, either directly as QX being 0.03, or indirectly, but almost immediately seen, as PX is equal to 1 minus 0.03, for example. So we plug them all in, and we do the calculation, and this comes out to be about 10,131.1724. And then the net premium reserve at the end of the first policy year is best calculated retrospectively as the accumulated actuarial value of the premiums minus the accumulated actuarial value of death benefits. So that's equal to P times 1 plus I, the premium accumulated with interest, minus QX times 100,000, that's the death benefit. And both of these are clearly calculated at the end of the first year, so that's when the reserve is calculated. But the reserve is only calculated for those who survive, and that's why we divide it by PX, because PX times the reserve has to be equal to what we have in the numerator. And we plug in the numbers that we have, so this is 10,131.1724 times 1.06 minus 0.03 times 100,000 divided by 0.97. 0.97 is 1 minus 0.03. And QX is given as 0.03. And then we calculate this is approximately equal to 7,978 0.3946, which is answer D. Please remember this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.